Hello all, I'm back for under note for section 5.3. I want to just quickly do one of the homework questions from our last day. I'd left you with questions on page 177, and I also asked you to try some of the questions on page 178. So I'm going to do one of the questions from 177 first. I'll do question 4 from page 177. It says you have a Canadian nickel. It contains 8.13 times 10 to the 20th atoms of nickel, the element nickel, along with other metals. How many moles of nickel are in a Canadian nickel? Right, so it's asking me to calculate the number of moles. Number of moles, remember, is little n. We're told that a nickel contains big N. The number of atoms is 8.13 times 10 to the 20th atoms of nickel. And if I look back at my formula, I know my formula says little n is equal to big N over Na, which is 8.13 times 10 to the power of 20 divided by 6.02 times 10 to the 23rd. Remember, that's Avogadro's number. It's on your periodic table, and we're going to be using that number a lot in this course. So kind of get used to using it. You probably won't forget it after a little while because we're just going to use it so many times. We all know what pi is, right? 3.14. We'll all remember this number too. So if I take my 8.13 exponent 20 and divide it by 6.02 times 10 to the 23rd, I get 1.35 times 10 to the negative 3 moles. All right. Now, you may have noticed in Mr. Sinha's notes that I've posted solutions. I'm building a set of answers for the textbook. It gives you some answers, but it doesn't give you all the answers. So I'm specifically going through and trying to fill in the gaps. I'm putting in the solutions as I do them for the chapter reviews. The textbook actually gives us answers at the back of the book on page 393 for practice problems, like the ones that we just did. So it tells me that for page 177, let me just double check this now, we're here. Question 4 is 1.35 times 10 to the minus 3 moles. Okay, so those answers are in the back of the book. But if you do the review questions on page 178, the answers are not in the back of the book. So again, I'm going to just continue to try and, I think I did all those questions and I put the answers in the hub in that folder that's called textbook answers. Okay, so for today I want to move into section 5.3. 5.3 is where we actually get into probably the most useful parts of chemistry for chemists. As a chemistry teacher, as a person who used to work as a chemist with a lab coat on and goggles and doing chemistry every day, 5.3 is what I did basically every day. Right? So as we move forward here, 5.3 looks at why this number here. We talked a little bit about 6.02 times 10 to the 23rd, and we said the reason why Avogadro came up with that number, and he didn't even realize at the time, but it has turned out that that number ultimately ends up being the number of protons in 1 gram. So if I gave you that many protons, if I gave you this number of protons, it would weigh 1 gram. So I could give you a gram of protons. I couldn't, but if I could give you that many protons, it would weigh a gram. If I gave you this many neutrons, it would weigh a gram. And if I gave you an atom that had 6 protons, and I gave you this many of them, it would weigh 6 grams. And if it also had 6 neutrons, it would weigh 6 more grams. So that would be a carbon atom. right? A carbon atom has 6 protons and 6 neutrons, and a mole of each of those is a gram. So if I have a mole of carbon atoms, it automatically will have a mass of 12 grams. Now, if I take that information and I use that information as a chemist, it allows me to figure out how many particles I have if I know the molar mass, the mass of 1 mole of a substance. Now for the elements, the molar masses are right on the periodic table, right? The molar mass for carbon is 12.01, the molar mass for neon is 20.18, the molar mass for cobalt is 58.93, molar mass for sodium is 22.99, right? That is grams for 1 mole, grams per mole, or molar mass. And the important thing here is the molar mass is given the symbol big M. Okay, that is molar mass. So the molar mass for carbon, the molar mass for neon. Right? Now, if I want to calculate the molar mass for a molecule, well, all I have to do is add up the masses from the periodic table. So the molar mass of a H2O molecule, if I gave you a mole of water, right, how much would it weigh? Well, I would have to take the mass of the 2 hydrogen atoms that are present, and I have 2 moles of hydrogen in 1 mole of water, and I have 1 mole of oxygen in 1 mole of water. So H2, 2 H's, hydrogen is 1.01, 2 hydrogens plus 1 oxygen. Oxygen is 16.00 on the periodic table, and if I add them up, I end up with a molar mass of H2O. Remember, molar mass is capital M, right, of 18.02 grams per mole. So if I was to give you 18 grams of water, right, it would be exactly 1 mole, 6.02 times 10 to the 23rd molecules of H2O. Now, the textbook asks us to do a couple of sample questions here, so I'm going to very quickly look at these 2 that are down here. The first one's asking me to calculate the molar mass for CH4. So the molar mass that's right here, the molar mass for CH4 is equal to 1 times the molar mass for carbon plus 4 molar masses for hydrogen. Molar mass for carbon is 12.01, and 4 molar masses for hydrogen, 1.01. Again, remember these numbers come from the periodic table. I have to look up carbon, and I have to look up hydrogen on the periodic table. Okay, and once I get that far, remember your order of operations. I'm going to do my 4 times 1.01 first, my brackets, and my 1 times 12.01. So this becomes 4.04 and 12.01, and I'm going to add them together, and I get 16.05, and the units are always grams per mole. Okay, what does that mean? It means 1 mole of water, right? 1 mole of water has a mass of 16.05 grams of carbon tetrahydride, sorry. Now, if I do aluminum nitrate, AlNO33, okay, let me erase this one because I need this working space here. Okay, if I try to do aluminum nitrate, the trick to this question is figuring out how many atoms of each are present. So if I look at the aluminum nitrate here, right, I got to figure out how many atoms and what are there. I see aluminum there, I see nitrogen there, and I see oxygen there. How many aluminums? There's 1. How many nitrogens? Well, there's 3 NO3s, so I guess I have 3 nitrogens. Right? Remember, NO3 means N1O3, and I'm going to multiply the 3 outside the brackets into the brackets. And the same thing, if I have 3 NO3s, means I have 3 oxygens or 9 oxygens. Multiply 3 into the brackets like we do in math. Okay, so now to find my molar mass for aluminum nitrate, I need to have 1 times the molar mass of aluminum plus 3 molar masses for nitrogen plus 9 molar masses for oxygen. Again, remember, these numbers come off the periodic table. Right? So now I'm going to have 1 times the molar mass for aluminum. So I'm going to do this as we're working along here. 26.98 plus 3 molar masses for nitrogen on the periodic table. Nitrogen is 14.01. And 9 molar masses for oxygen on the periodic table. Oxygen is 16.00. So if I add all those numbers up, I get, I don't know what I get. Let's do it quickly. 9 times 16 plus, open my brackets, 3 times 14.01, close the brackets, plus 26.98. I'm getting 213.01 grams over moles, grams per mole. Right, so my molar mass for aluminum nitrate, right, is 210.1 grams per mole. What does that mean again? It means that 1 mole of aluminum nitrate has a mass of 210 grams. All right, I'm going to leave you with questions 8, 9, and 10 here on page 180. And question 5 on page 185. Question 5 on page 185. All right, so when I come back to my next note, which I'll probably finish later today and then post maybe tomorrow or Monday morning. Actually, I might even post it later today and then you've got it. I will